Dear students, today we are going to see about the patient monitoring systems and ICU monitoring system. That is actually the unit 4 of biomedical instrumentation. That is, we have completed unit 1, 2 and 3. In unit 1 we have seen the introduction and the origin of the biomedical engineering, where we studied about the origin of biopotentials and all. Okay. And in unit 2 we studied about the electrodes and transducers. What are the different electrodes used to pick up the different biological activities from the human body, and also the transducers. Different pressure transducers, flow transducers and all we studied in unit 2. And in unit 3, we have seen the different methods of measurement of different non-electrical parameters. Non-electrical parameters in the sense, excluding the electrical activity from the human body, like ECG, EMG and EEG, which we covered in unit 1. That is along with the introduction to biomedical engineering and the origin of biopotentials and all. We studied the basic electrical parameters measurement from the human body. The basic electrical parameters that are measured from the human body are ECG, EMG and EEG, which we very well covered in unit 1. And in unit 2, we covered the non-electrical parameters from the human body, that is like blood pressure, blood flow and the cardiac output measurements and all we completed in unit 3. Of course, along with that, several other headings also we completed, like respiratory monitoring systems, ventilators and all we completed in unit 3, second half. Now coming to unit 4, it's a very unique content, that is there is no typical technology involved in this particular unit. Means it is a combination of all. When a patient is going to the hospital, what are the primary parameters? Or otherwise, when a person is kept in the ICU, intensive care unit, what are the parameters that need to be continually monitored by the doctors for the emergency situations? So that is what we are going to study in this particular unit called patient monitoring system. So that is what I mean that the patient monitoring system is not unique by itself. It does not have any new technology. Whatever we have studied in the 3 units, all are combined and put together as a patient monitoring system. And what are the specific requirements when it is a monitoring system or it is an intensive care unit monitoring system? What are the specific requirements? Some simple theoretical concepts we will study. So I am not going to explain in detail all those things because there is no block diagram and connection one-to-one connected explanation at all. A very general discussion, theoretical discussion will be based on will be given for the patient monitoring system and intensive care unit monitoring system. So suppose you have to think in these terms. Suppose you are going to a hospital or you are meeting a doctor. What are the parameters that are primary parameters? A serious case or a normal case. Whenever a doctor is met, immediately they will be taking the temperature, blood pressure, heartbeat rate, if required ECG, and keeps on adding parameters. So these parameters which I told in the beginning, that is temperature, heartbeat rate, ECG, these are all the primary parameters that need to be monitored for any serious patient in an intensive care unit. And that is what a patient monitoring system is all about. Okay. What is a patient monitoring system? Okay. So let us see in the syllabus the elements of intensive care monitoring. What are the different elements in intensive care monitoring we are going to see, and what is the patient monitoring? That is what we are going to see in the first half of the unit. And of course in the second half, we are going to study about the displays, diagnosis, calibration, the repairability of the patient monitoring equipment. In case of diagnosis, it is not new. Whatever diagnosis we already studied in the first 3 units, we are going to combine everything. Other instrumentation for monitoring patients, organization of the hospital for patient care monitoring, and of course some new headings we are going to study in the end of this unit. That is pacemakers, defibrillators, radio frequency applications of therapeutic use. Okay, how radio frequency is applied for therapy. Okay, so when we discussed in unit 1 itself, we told that most of the equipments, almost more than 90% of the equipments in biomedical is used for diagnosis only. Diagnosis in the sense identification of the disease. For that we are going to use only major of the equipments are used for diagnosis only. Very few equipments are used for therapy. Like for example, pacemakers, defibrillators. Through the equipment you are going to give some treatment to the body. Normally if you see in a hospital, if you collectively see, 90% of the equipments are used only for diagnosis, whereas very few equipments are used for treatment like pacemakers, defibrillators and some radio frequency applications used for treatment. So those things we are going to study at the end of this unit. Okay. Now what is patient care monitoring? Okay, let us explicitly see what is given in your textbook, because there is no typical new information in this particular heading. Okay. Careful and accurate monitoring of the patient in intensive care units. So particularly in intensive care units, careful and accurate monitoring of patient is required due to this electronic medical instrumentation. Due to the advent of the electronic instrumentation and high-end equipments only, careful and accurate measurement of different physiological parameters is possible. That is a general point that is given. In case of an event of the heart attack or stroke, okay, we are coming to the point when this intensive care unit, monitoring unit is like surgical operation. So heart attack is related to heart, stroke is related to brain. Okay, the immediate, the emergencies are to execute a surgical operation. When a surgery is being done, all these parameters should be simultaneously monitored. So to avoid separate instruments for each of these purpose. For example, to take BP one particular instrument, to take the heartbeat rate another instrument, to monitor the ECG another instrument. Likewise, you may be required to install 10 to 20 equipments in a particular surgery room, which is very highly uncomfortable and highly demanding more cost also. So a patient monitoring system is an integrated system where all these parameters will be simultaneously displayed. Always the doctor is not going to make a decision based on a single component. He is going to make a very complex phenomenon of combining all those parameters and coming at a very subjective conclusion. Okay, he may be able to understand what are the interconnections between these two based on his experience. So he may give a subjective conclusion based on all these parameters. Okay. So when this patient monitoring system or intensive care unit monitoring system is NetB, generally, what is the role of a biomedical engineer? It is given. Okay, not only fits for this particular monitoring system, so it is a very general thing. What a biomedical engineer is expected to do. The role of the biomedical engineer will not stop only on the design of the new equipments. He has to install it, he has to commission it, he has to transfer the knowledge of operation to the clinicians. That also is under the umbrella of the biomedical engineering. Biomedical engineer is expected. That's a very general point is given under this heading. Generally, the biomedical engineer is responsible not only for designing and R&D of the appropriate equipments. He is also responsible for the safety measures, installation, training and maintenance. Elements of intensive care monitoring that is being continued. The nurses have at their disposal powerful tools for acquiring and assimilating information. That's what is very important. Powerful tools in the sense cutting edge equipments for acquiring and assimilating information. Assimilating information, the heartbeat rate alone will not give any new information. The heartbeat rate when combined with the blood pressure, when combined with the temperature, all those parameters will give weightage for a particular disease, presence of a particular disease or absence of a disease. Okay. So likewise, assimilates. Because of the ICU monitoring, the physician are able to react promptly and properly to any emergency situation. So two things are very important in this particular intensive care unit monitoring systems. There is nothing but continually the monitoring should be done, and wherever the emergency situations are there, that should be perfectly identified at the right point of time, because every second counts here for the intensive care unit patient. Patient monitoring system provides an immediate alarm. That's what an immediate alarm is given whenever any of these parameters goes to a danger level. This is continually monitoring and also critical monitoring. Critical monitoring in the sense, immediately the physicians and nurses should react on hearing the alarm or any abnormality is being sensed. What are the primary parameters? As I told in the beginning of the discussion itself, the primary parameters are nothing but whenever you go to a doctor, not only for the critical care or intensive care, a general fever itself, what are the primary parameters that is taken from any human being? The same is the case with any particular intensive care unit person also, because he may be suffering from any other disease, but these are the primary parameters. Of course, additionally, several other parameters are also added depending upon the disease what he is suffering from, or depending upon whatever surgery is being done. Primary parameters may be added. But basically, this book is the availability of electrocardiogram, prompt to the monitoring and the warning system. So, monitoring and warning enables the physician to give the patient the correct drug rapidly. Whenever the heartbeat rate falls below, or whenever the ECG is abnormal, a correct drug or correct therapy should be given. Pacemaker should be given whenever the number of pulses falls below a particular threshold. That's what the ECG. ECG is a primary parameter, as I already told. Temperature measurement is also quite frequent. So temperature measurements are also frequently taken. There are several parameters such as blood pressure, which may be measured not so frequently. Even though it is not written not so frequently, we know that blood pressure is also one of the very primary parameters which becomes high or low. High BP or low BP is also continuously monitored. However, if continuous measurement of blood pressure is needed, it requires catheterization of the patient. There is a direct measurement of blood pressure we are talking about. Whenever whatever we discussed in the unit 3, indirect blood pressure measurement, a cuff is placed over the human arm and it is being inflated and deflated to hear the systolic and diastolic pressure. That is an indirect measurement without disturbing the human body. That is non-invasive. Non-invasive in biomedical is nothing but you are not disturbing the human body, or you are not invading the human body. Whereas invasive measurements are nothing but you are invading the human body, like in the typical case, whatever it is given. Sometimes It requires catheterization of the patient. What is the catheterization? Catheterization is nothing but a catheter is a small needle or a probe that is given into the human body, that is used to invade the human body and to place the appropriate sensor or transducer on a particular point. So here, when it is surgery is being done, already as the body is being surgery. So what it is, the transducer are placed directly into the blood vessel itself to pressure the blood pressure. The basic elements of intensive care units are as follows. So what are the basic elements? So right now we have discussed about the introduction. So in the introduction we saw very elaborately that there are two things: continuous display and continuous monitoring, and also emergency reaction. So whenever there is an emergency, that is should be reacted with the appropriate treatment. That is what is the importance of a patient monitoring system. So what are the basic elements? Let us see. Skin electrodes to pick up the ECG potential. So any patient monitoring system having the intensive care unit, that will be having all these things. Because we know ECG, one of the primary parameters, the ECG electrode should be available. Amplification unit for the electrocardiogram. So we know obviously whenever there is a ECG or any biomedical signal, there should be an amplifier, because all these biomedical signals are very low in amplitude and also low in frequency. We are not now bothered about the low frequency. We are bothered that the signals are very low in amplitude, that is in the range of millivolts. Millivolts in the range 10 power minus 3 volts. Okay, they have to be amplified to the range of volts. That is a very high gain instrumentation amplifiers are required with the gain of around 10 power 3. That's why then only we can convert that 10 power minus 3 volts to 10 power 3 volts. So likewise, very high gain instrumentation amplifiers are required. So amplifiers are required. So all these things comes packed within the equipment itself. But what are all the different components in a patient monitoring system we are seeing? CRT display. So of course, after picking up all these signals, obviously it should be displayed. CRT display for observation of ECG waveform. The central nervous station normally can have CRT display of several patients on the same screen. Likewise, if for example 5 to 6 IC units are there, okay, each unit is having its own ECG and all. In a central room where the clinicians are available, all the ECGs are being displayed. So whichever patient goes abnormal, he can be immediately treated with. So that is what is the idea. Centrally monitoring is also done. For all, a rate meter to indicate the heartbeat. So the number of heartbeat is also an important parameter. Apart from the ECG, we have to continually look at the ECG, whether the pattern is normal or not, whether the PQRS, P height, P waveform height, QRS waveform height, and the time duration between the P waveform and Q waveform. Everything gives a particular diagnostic information as we studied from unit 1. That is also important. Whether the physician has to be continually watching the ECG waveform, or otherwise what they can do, they can measure the heartbeat rate also. Whether the heartbeat rate is normal also can be seen. The rate meter is nothing but the number of beats per minute to indicate the heartbeat. It can have continuous indication with audible beep or flashing light. The beep is suddenly stopping, we can immediately react. The physicians can immediately react. Or flashing light at each heartbeat. So generally we know the audible beep sounds with each heartbeat is being done in the intensive care unit. So it becomes very involuntary for the physicians. It becomes very comfortable because whenever there is a stoppage of sound, they can immediately react based upon understanding that the heartbeat is lowering. So these are all the additional points we are studying in the intensive care unit or patient monitoring system. Apart from that, everything we know. What is in the ECG, what is in the blood flow rate, what is in the cardiac output, and what is in the blood pressure, and how these things are measured, and what are the sensors and transducers for all these things. Now what we are studying is how specialized all these are used in a particular intensive care unit and how they are combined and how the information are being extracted. So these general things only we are seeing in the beginning of unit 1 under the heading called the intensive care unit displays. An alarm system is actuated by the rate meter to alertiness. So as I already told, an alarm system can also be used, should also be used in the intensive care unit monitoring system. A memory tape to record the playback of ECG for every 15 to 60 seconds. Last 1 minute ECG will be recorded at any particular time so that the physician can verify that. So a memory is also required in the intensive care unit. Patient monitoring system of the intensive care unit. Additional alarm system triggered by ECG parameters. We can keep on adding depending upon the patient or depending upon the demand by the physician. We can keep on adding the alarm system. Several patient monitoring systems even have alarm for the saline bottles. Whenever the saline is going to get over, there can be an alarm system. Likewise, depending upon the make or depending upon the demands of the patients and diseases of the patient, we can design alarm for different applications. Likewise, an additional alarm system can be triggered for ECG parameters also. Electrical circuit to indicate the electrical connections have been disconnected. Suppose every electrode is being kept in the patient, being kept over the patient. For example, to measure the ECG, heartbeat rate, the electrodes are being placed. Sometimes EEG may also be monitored. So in that case, the electrodes may be placed over the scalp. Whether those electrodes are connected properly, or any open circuit happened, or any electrode has been detached. That we can also have a circuit to identify that open circuit. That is what. Failure which may be because of some movements of the patients or anything else. Some by mistake, any mistake, the electrodes get detached. That has to be also automatically detected. Instead of expecting the physician or the nurse to check the correct placement and the positioning of the electrodes then and there. It is always better to have an automated system which will detect the detachment of electrode from the human body in case of the ICU, which is very, very crucial. A closed circuit monitoring system is also employed to provide visual coverage using cameras focused on each patient. Okay, a complete video recording of the patient lying on the bed and all these monitors. Of course, in the camera we cannot observe the parameters. The current physical situation of the patient can be seen through the camera. What are the other factors that are influencing the intensive care monitoring system? A closed circuit is also employed to provide visual coverage using camera. Okay, the same point is get repeated. Noise and movement of artifacts may give false alarms sometimes. So what are the other things we need to bother is nothing but sometimes noise and artifacts may give to unwanted false alarming. So false alarming is a major problem. Okay, if the physician keeps on running and getting attempted and getting failed, that the patient is not having any problem, but false alarm is being given now, that also becomes a crucial factor. It should not be very frequent. Patient monitoring equipment is generally specified as a system. A wide variety of configurations can be seen in the hospitals. That's what I told, depending upon the maker, depending upon the demands of the patient, depending upon the demands of the physician, different types of patient monitoring systems are there. The below figure shows one of the patient monitoring systems. So this is the overall block diagram of a patient monitoring system. That is, a central CPU is there, and we are having the measuring devices and its analog interface. Measuring devices and its analog interface in the sense, there are several transducers that are attached to the human body, and the analog signals are being taken from there. And all these parameters, either they may be continuous values or discrete values. All those values are being multiplexed and given to a to D converter. Why it is given to a to D converter in the sense, in the computer you can store it in the digital form. It is being stored in the digital form, and that can be taken for RAM and ROM. RAM for random access memory and read only memory. And you have some keyboard interface which has only the input, there is no output. There is some data storage also, provision for some data storage also. We can store the data. So we can print the outputs also, and analog output display and digital alarm. So this is the alarm and display that is given here. Generally this keyboard and video processor will be taking only the output, I think. This arrow is not necessary. And similarly display should be taken this side arrow. An A to D converter, and that is given to the CPU, and that CPU will be able to display and print the output. So this is a very main part of the heart of the patient monitoring system. So regarding the displays also we need to study. So non-fade displays and fade displays they call. So they won't call it as a fading display because the next one is called as a non-fade display, simply told as a fade display. General types of displays, olden days display or some preliminary types of displays are there where you can see a dot going as a signal. We have to trace the dot to understand the signal. Recently non-fade displays have come that will not fade for a particular period of time. For example, for 1 minute the particular display is able to hold the particular waveform. That is called as a non-fade displays. Everything is being displayed on a CRT screen only. Let us see what are they. The CRT displays are of 3 types. That is conventional displays. Conventional displays in the sense horizontal sweep. What is by the sweep? Something to display any signal. A horizontal x-axis line should be drawn. Over which only the signal will be drawn. That is called as a horizontal sweep. By a slow speed sweep. We have slow speed sweep also, which causes the electron beam to move from left to right at a predetermined rate of 25 to 50 millimeters per second. So in a slow sweep waveform recorder, it is only 25 to 50 millimeters per second. The horizontal sweep will be drawn. Of course, when there is variation on the signal, the horizontal trace will go up and down. Okay, even though it is written left to right. Only a straight line from left to right is of no meaning. So whenever there is a variation, there will be a movement, slight movement up and down to trace the waveform. As we already know that all these biomedical signals are very low frequency signals, the variations will be very smooth. So the horizontal sweep will be moving up and down also to draw the waveform. The sweep is very slow. That is what is called the conventional display. Whereas the bouncing ball display, the sweep rate is very high. This is also a CRT arrangement just like the previous one, wherein the sweep rate will be very high, such that the display appears to be a continuous display. Okay, you can imagine a single dot moving very fastly, so you can immediately see a particular waveform being drawn on the CRT screen. Each spot of light seems to be bouncing up and down. So because it is moving very fastly, each dot will be like moving up and down. So it is called, that's why it is called as a bouncing ball display. So these both two are fading type of displays. That is, a particular dot only moves. So the doctor has to visually, clearly and carefully see the dot moving so that he can understand a particular pattern. An ECG pattern in the sense it is moving like this. But he has to trace it with his own idea. That is a fading very fastly. Okay, suppose if on a particular period of ECG waveform is for 5 seconds, some 5 seconds it is being drawing, but the fading happens every 2 seconds now. When the later portion of the ECG waveform occurs, the frontal portion of the ECG waveform will be disappearing. So the doctor will not be able to see a complete period of ECG, not even a single complete period of ECG waveform he will not be able to see. So that is a drawback of the fading type displays. And later came the patient monitoring display, non-fade type displays. The non-fade type displays are like this. A dot is completely traced over so that the doctor is able to see at least more than one complete time period of the particular waveform. So here we can see a ECG waveform, 2 periods of ECG waveform, 2 repetitions of ECG waveform, the doctor is able to see at a particular period of time. The non-fade display, it also uses CRT display. Here also cathode ray tube displays are only used, but the electron beam rapidly scans the entire screen. So the movement of the electron beam is very fast, likewise such that we can see the entire particular waveform in a particular given period of time. In a television like raster pattern. So a television like a series of dots on the screen as shown in the following figure. As shown in the following figure, a series of dots can be seen so that we can understand the particular ECG or any other type of waveform. Brightening signal is applied only when the beam passes a certain location, that is to contain part of the display wave, from at which time it produces dot on the screen. A brightening signal can also be applied, so that particular signal will move over the contour of this waveform so that the person can understand, the physician can understand what type of waveform is being generated. Of course, this dotted line will be already there, over which a brightened dot will be moving. So that is the additional feature in the additional physician will be able to observe more than one period of the waveform. Then only you can understand what problem is occurring within the